All right. Let's go. All right, so for today, I'm going to continue to trying to implement the pipelines. One thing that we do want to have is multiple sources in the streams. So let's go ahead and do that. So now we have a thing called source, and it's just one item, but we need it to be multiple. So let's make sources, which is an array list of closable readers, exit code. All right. And let's see what we can do here. So connect source will presumably just append now. So sources append I think we have the allocator here now. And then this is the source. Okay, I'm gonna comment out this for now. Okay, here's connect destination. Now, when we connect the destination, we actually stream out whatever's in source to the destination. But since now we can have multiple sources, we have to loop and instead of doing this, I want to do just that. Yeah, disconnect source. Now disconnect source needs to change because we don't really know which source we're talking about. So I guess we would say something like index and we will, let's just do a swap remove, it doesn't matter. Okay, now we need the index, so let's add that. And of course, if we delete the index here, it's gonna mess with our index. So what we'll do is I'll have to create a list. Let's see, sources to remove. And let's have a list of indices. Do we have allocator? All right. And so instead of disconnected source here, we will say sources to remove append and the item is I. And then over here, we're gonna loop through sources to remove items. And there we go. Oh, but if we do a swap remove, wait, this doesn't work. Wait a minute. We could do like many. Let's do sources. We'll make, okay, let's make another function that is like removes disconnect sources. And we'll do order removed any. And I guess we could like sort it before, or we have to sort it before we. It's well, how is it sorted? Is it sorted from large to like? It is a need to be or sorted ascending. Okay. Let's just sort it here, whatever. Mem sort. Okay, now this has to be constant. No, let's sort it before, because so we'll sort these. With a less than function. Context, I guess, self, doesn't matter. Less than is. Do we like? Less than. No, you can't use this. Because that's a type. Oh, it's a slice thing. Okay. Oh, I see, I see. Okay, well, whatever. Let's just do like less than. I thought there was, maybe there is some built-in function somewhere, like a standard function that you can use, but no, this is this is at this, and then we have usize, and return the goal, and we return if this is less than this. There we go. And then we don't do this. Oops. No, what we do is we do sources. Yeah. Okay. And let's see. Well, another thing. No, that's fine. I was thinking like we implement the reader interface, but we don't. Yeah. Okay, so forward source is self-source or else no source connected. So this thing should probably happen like for all sources. This is just checking destination. But the problem here is like, okay, I think here we need to disconnect all sources. Or close all sources. And we have disconnect all sources, or sources all, which would just be clear. No, wait, we just deinitialize. There we go. Okay. Although, no, clear and free. I think clear and free sets capacity as well. Yeah, there we go. We should do a clear and free because we might reuse it. Okay. And this would be close sources now. And this would be disconnect sources all. I'm gonna add this as well, like close destination for convenience. Because we wanna check this first. Oops, excuse me. Alright, so instead of doing this, we do close destination. Okay. Right. If destination is closed, we close sources. Okay, right, but this should only happen like once. So I'm gonna move this up here, and then here we have like, I think we're gonna have a like a loop of all sources. The problem here though, if the source ends, we need to change this a little bit. So if the source ends, we want to check first if it's the last source, then we do this, I think. Otherwise, we will be not done. So this whole thing is gonna be copied now. So I'm gonna, what is this doing here? Basically return, and then it's like, no wait, we don't return. Here we just continue actually with the rest of the sources. Here's like if we should close, but this is repeated, so I'm gonna say like if should close ends, we get the event out, and then we return this event. We get a, what is it? Forward event, I think. Yes. And then return null if we didn't get it. So there we go. Now we can say this instead. All right. Now we need to have this in a loop. So for sources source, and I guess if we don't have any, we will return no source. That's this case here. Alright, now we need the index. Oh. Okay, so we need kind of the same thing happening here. It's like we need sources to remove and defer. In the defer, we do the disconnection, I think. So first we'll do sort, and then disconnect sources to remove items. So that is going to happen whenever we exit this scope. This is gonna execute, so we're gonna remove all the sources that we need to remove. So now we don't need to worry about, okay, because we can exit the scope Now this should actually happen down here. And here we don't really do this, we do continue. And here we say sources to remove, append. So we still need this here. And then we just continue. However, I think we do want to have this like after we've done the disconnection, actually, okay, we have to do a check out here. So actually, let's not do this over here. We'll do this down here. Yeah, and after this is done, because we don't actually return in here. I don't know what I was thinking here. Actually, we do return here, although then this would already handle this here. Whoops. Yeah, this actually closes ends. Also, this function is badly named, but maybe I should just call this handle to be like imply that something might happen, some kind of side effect might happen in here. Or process maybe. Whatever. Let's just do it like that, and then yeah, we definitely want to initialize the end. Wait, where's the allocator? Let's do that. Okay, so we're not returning. No, we are returning. We are returning, yes. That's true, because it's the last thing. Although if we're returning... Yeah, if we're returning, that means we didn't write any data anyway, so we don't need to flush. And this should be the last source, which was closed, so then we just return this event. That's fine. But if we're down here, that means we have had some stuff happening, and we might have closed all the sources. So we want to check here. This whole thing happened if all sources was closed. So basically, we just want to check if we actually have any items in here, or if we don't have any items. So if we don't have any items, normally we would close, but we have this config keep open, and then we're not done. So yeah, so if the sources was removed or closed, where everything is closed. But if we have sources left, we're not done yet. So there we go. Unused, yeah, fine. Okay, we need to add... Oh, I see. Let's just do this then. Man, this is gonna pollute so many things. But, okay, whatever. Actually, it's not whatever. Maybe. We'll see. Expected type void found. Oh, there we go. Actually, we could pass in an allocator maybe. Whatever. Okay, that was it there. Source is closed. Let's add a convenience function for this, I guess. Source is closed. I mean, it would just be is source closed? Wait. Is closed. If it's not closed, we're gonna say result is equal to result and is closed, right? So at the moment where something is not closed, and actually, okay, this is stupid. We could just say if source is closed, or if it's not closed, return false. Otherwise, return true. There we go. Because now we exit prematurely here if the source is, if we find a match. All right. So now we can use that instead. We can say is source is closed. Okay, now we're in like this part. And this is like the old code, so I'm not actually worried about this. But I think this would be a simple fix here. I think disconnect source. So before the intent was to disconnect all sources basically, so let's just do that. Hello, someone. What's up? Welcome. Get pipeline exit code. You know what? There we go. Don't worry, be happy. Okay. How much time did he spend making this? I've been working on it for like... When did I start? I mean, it's been like a month or... month and a half or something maybe. Alright. Okay, so where are we now? So now we have multiple sources. We fixed all the compiler errors. And now what's hopefully is going to happen is that whenever we connect multiple things, like in this example here, we connect multiple things, like each one connects to standard error here, or here I mean. And so standard error will actually have now multiple sources, and that's all being forwarded. So yeah, and but yeah, I forgot what the issue was last time. I think it got stuck on something. But let's just run the debugger here and see what's happening. Alright, so if we look at the threads. Now this, yeah, this is the first pipeline stage. And this is the main thread, which has now created the first pipeline stage here. And now we're on to yeah, the last pipeline. And you create the executable call. And now we're forking another one, which is the last stage. And you're waiting for this, you're streaming. Push. So yeah, I'm gonna have an eye on this. This stream should stay. If it doesn't, then we have an issue. Alright, that's preparing to call the executable. And here we're preparing to create the executable thing. Main process now waits for that thread, the last thread. No. Yes. Let's see if this all works. So standard in, this pipe, standard out, standard error. This fork has standard in is this pipe, which makes sense, and that's normal standard out, standard. Yeah. And you're still streaming, which is good. Good, we're stuck there. You're executing the program. And here we're forking another executable thread. Main thread is now sleeping. You're still streaming there, good. This one is waiting for the process. And you are waiting for the thread, so now you go to sleep. Good. This one is preparing there. The stream, yeah. Standard, the standard IO streams. Still doing that, great. You're still waiting. Now we execute the second executable, which is cat. Going through these. Yo, cold guy, what's up? Welcome back. And now, oh, now this stream is done. Okay, I guess it technically could be done. Yeah. So Echo has been, Echo has done its thing. Thread 5 Echo now is done, so that's good. And this one is now waiting, still waiting for this thread here. Or executable. So this one should end, yes. And you're waiting. So for some reason we're still waiting on the last. Yeah. Cat never closes its things. Did you submit language to linguist? Well, it's not fully complete yet, so I don't know the process there. I wouldn't wanna like try and get my incomplete language into linguist. Why is that waiting? All right. Hello, Two-Step. Welcome back. Yeah, it's going well. Making progress. How are you doing? It's like, what is it waiting for? That's what I want to know. Let's enable logging here. Okay, are we in the loop now? Yeah, I think we're in the loop. Okay, I want to do like whenever we try to get the result, I want to write out what is the status of all the pipes. I will not make a game with. You will not make games with Runic. Hello, Code Langton's Entropy. Welcome. When is this project? Just out of curiosity, why did you need a new Bash-like scripting language? Basically because I wanted to make a language, and I was starting to make more and more Bash scripts, and I was tired of like looking up how to do things in Bash, and I didn't want to look up any alternatives because I didn't want to get. I wanted to make my own kind of take without any influence. But Runic will not be able to make. I mean, it's a scripting language, so you're not gonna be making games with it. I mean, I guess you can make. You could probably make some kind of terminal-based game, maybe, like a text adventure game. Debugging is the pipe example. Yeah, the debugging is this example here that I have. I like Zig, yes. So this is a very simple example here. Is that what you're asking, Two-Step? With Echo and Cat? So this Echo, so what's happening is that first, I wish I had a way to only print the instructions, but if let's say I open up the other example here. So this is an example, except it has another cat here. So this will compile into these instructions down here. So basically, so what's happening is that for each, so this is a pipeline, and each like thing in between the pipes is called a stage. And so we have 3 stages in this pipeline, and we have 2 pipes in between each stage. So the number of pipes in a pipeline is the number of stages minus 1. So we have 2 pipes in a 3-stage pipeline. So what's happening here is this thing here is the standard in, standard out, standard setup. So this is happening for all programs, like this is a common setup that we have. But down here is the actual code starting. So first we create these 2 pipes. These are stored in what's called a ref, which is kind of like just a magic location where you can store any kind of value. So we create this is like declaring a ref with ID 0 or address 0. And then we set the ref 0. So this is how refs the ref kind of identifier looks here. To a new new pipe, which is read and write stream is like it's like a pipe. And then we create. So here we create 2 pipes, and then we fork. We spawn some threads here, so for each stage in the pipeline will have its own thread that will make sure that the pipe will forward its, like we're reading from the source and forwarding it to the destination. So each stage would have its own pipe, which will handle that. I mean, technically we could just have one pipe for each, or one thread for each pipe that will churn through that, which is probably better. I should probably change to that. But anyway, this is how it works right now. So we have this will be created in this fork here. So here we're forking to the instruction set number 4, which is all down here. So here we're spawning the executable. Now this is not exactly how it looks in the code, because we have 2 stages, and also for each time we're doing this, like we're spawning, this actually happens in its own thread. But so this is like simplified a little bit, but basically here we are since exec is, yeah, these 2 instructions together will execute this executable with echo hello. And then wait actually this is not like a full example. So actually we have like a ref here, and this will be that ref, and then we wait for that ref. So basically exec will store its handle in this ref, and then we wait on this on the handle here, and so yeah, so this thread will now wait for this executable to finish. Okay, so that's happening its own fork there, and then we have the second fork, which is now for cat, which happens with set 5. Now also notice here that we have 3 arguments here. This is standard in, standard out, standard er. That is like the context of this thread will have standard in, standard out, standard er set to these things. So whatever's happening in this fork, it will kind of it's like a redirection. So we redirected standard in. Standard in is actually inherited here. So this means the actual standard in. This means the actual standard er. Here we're actually setting that, hey, standard out should be redirected to this pipe here, which is this pipe that we created here ourselves. So this is like an in-memory pipe that can have data there. So and then the second, so this is for the first echo hello, right? It takes from standard in, but yeah, and then it connects standard out to this pipe here, and standard er is just connected directly to standard er. It's inherited. And then we have the second fork here takes this pipe as an input, which you can see here clearly in the kind of like this code here. It takes this pipe as an input, and then the output is the second pipe, which is declared, created down here. So that's the second pipe, and then standard er is still inherited. And this is now set 5. So if we go down to set 5, we can see that we are now executing cat, and then we're streaming standard in. So this means that this will block here until this standard in stream is closed. So pipe 1 is 0 and 2 is 1. Yeah, so these exactly, yeah. This is the first pipe here, and then this is the second pipe. And then we spawn up everything and connect every pipe. So first we create all the pipes, and then we spawn up all the things that work with those pipes and redirect everything. And so then in the last one has standard in is this pipe here. Standard out is, you know, it's the inherited. Standard er is all still inherited. And then we wait for this last thread to complete. So now this whole statement, now we wait for the last thread to complete, and then we're done. But there's something wrong here. So there's something going on that's not working correctly, because we get stuck at the last. We get stuck over here. So that's what I'm trying to solve now. You need to learn this for cloud roles. Yes. Now, this is a new language. I mean, we're using Bash. So, or I mean, not using Bash, but where it's like a Bash-like language. So, I would say you probably don't really need to learn this for cloud roles. I mean, I'm guessing you're talking about DevOps. Or I don't know. I'm not super well versed with DevOps. You should probably just search for resources on that. Yeah, this instruction set is not. It's for one. It's not actually one-to-one what's happening, because these things are actually. This is actually stored in a separate thing. Or yeah, it's spawned in like a separate set actually, because all the executables, because this doesn't have to be an executable. This could be any value. This could be like a string or a function call or something. So this compilation actually is incorrect right now. What's happening? Because all executables are automatically have their own thread. So this actually spawns in its own thread. So actually this set4 has two threads here. So the sets are actually just, they are like, you could like their own, like it's just a bunch of instructions. However, we always as it happens now, we always connect it also to a thread that like spawns in that set. So right now, every set that we create is actually tied to a fork somewhere. So in that sense, it has its own scope, because the thread has its own scope. It has its own stack. I can show you here. Thread context. So so we have a shared context, which is shared between threads, and then we have a private context that has instruction counter, the stack, and then we can have an optional process associated with the thread. Now I'm not sure if we actually use this. This was like an old idea that I had. And then we also have this waiting for, which is like if the thread is sleeping and waiting for some other thread to complete, basically. Do you read the final standard out to pass it somehow at set end? Let's do this. I'm gonna do this. I'm gonna go to here. And we have enable IR. I'm gonna do dry run. So we can look at, I'm gonna add this option so that we can look at what is it? So that we can look at the instructions. And so now we have that. Now we go here and we go to over here, and I'm gonna say we add dry run here. Oops. And then we do all this, and if dry run is true, we return success here. And I never had this much activity in my chat before, so I have a little bit of trouble keeping up. Sorry. Yeah, thanks for the suggestion, cool guy. I will project. Okay. All right, so we have the dry run there. Now what we can do is we can go to build, see that it's built. We will enable IR for IR2. Actually, let's do it like this. No, IR2. And runic dry run. Oops, it needs to be verbose as well. Oh yeah, there's no coloring here. Actually, you know what? Let's do this. No, runic. There we go. We don't have a memory leak. Don't worry about that. And then we'll set. What was the file type? Was it bash? No. I forgot. Anyway, just to have some color. Color here. Alright. So now we can see this is what the compilation will be. Leak is fixed, yeah. You could use packed struct for all those bools if you're concerned. Oh, okay, cool. Thank you. I've never actually used packed structs. Actually, that might be a lie, because I've used it for serious. I don't know. Anyway, like once, maybe. So this is the compilation results of this program here. We have some read-only data. So we have this echo hello. And then this part is the executable call context struct data. And then we have cat, and then this is the same. This is also executable data, but for the second part here. So this, you can say that this is tied to the first call, and then this is like the second call. So we have this read-only data here. And then we have, yeah, this is struct type. This is like an internal struct type, which is the same as this. This is a byte representation of one of these. Okay, and then here's the instructions. Maybe I should change this. It's kind of hard to read. What? Markdown, maybe? No. Okay, sure. Runic. There we go. So first what's happening is forward standard IO. Now this kind of sets up, this is like the initial instruction of all programs. It sets up, it pushes things on the stack. So whenever you see like S0, S1, S2, S and then a number, S means stack, the number is position on the stack. So this is, so S0 always refers to standard in, S1 always refers to standard out, standard er. However, it might, you know, depending on the thread context, it might point to something else than the actual standard out, you know, or standard in or standard er. But for the main process here, this is set 0, so this is set 0. So this is the main process here. And you can see everything that's at null here means that it was generated from, like we don't have a source where it was generated from. It's basically just generated. Here we can see where this code comes from. So this comes from this first line here, which is the only line, of course, that we have. And so here you can see the actual instructions that gets done. So so we have this ref here, and all right, thanks. See you later, Code Langton's Entropy. So ref, yeah, that just creates a place for this ref for this pipe to be, and then we actually create the pipe here. So here we create the pipe. We only have one pipe, so this would be repeated however many we have. If we add one more, and we do this, you can see that nothing happens. Okay, here we go. I forgot to save. So here now we're creating two pipes. Here, two instructions. It creates one pipe. So we have create two pipes, and then we can. So now it's more akin to the actual example we had before. But let's just look at the more simple example first. Right. So we create this one pipe. We fork set 4. So here's set 4, which is an execution thread. So and then we fork again. And this was kind of what I was trying to say before, is that each stage in the pipeline has its own thread, but whatever's in here, this expression could be an executable, it could be a string or a function call or anything. So that depends on what's happening here, depends on what expression this is. And since it's an executable call, it actually forks again into set 5, which this is the actual executable instruction set here. So this here first creates a ref for the process handle, you can say, and then we push this executable call context data, and we execute. So these two instructions execute the thing like echo hello, and then we wait for this, and it's non-blocking as well. So this will, now we need an instruction here to wait for this process to complete. So this thread is now kind of blocked, which is this fork here, and then this thread now streams, and we don't really see what it streams, but it's streaming standard in. No, wait, it's not. That's right. Oh yeah, that's what I was gonna change actually. That's right. So the problem here is that this only streams the one pipe that we created here. But then we also need to stream. No, wait, but that should be enough. I should really add the output of this. Where is that happening? I think instructions. And format. Let's add stream here. Wait, but stream is just, yeah, it's a location. Yeah, that's fine. So let's do that. Okay, now we can see what is actually being streamed. Who is closing at the end? Yeah, so the stream, we don't actually see here, like the okay, it's kind of like hidden in the pipes. So each pipe, this pipe here, it will read from echo hello. Once echo hello is depleted, this will close the source, and then will also close the destination. So cat standard, it will forward the bytes first, of course, and then this thing is closed. So that should close standard in of cat, right? Now cat itself also implements an interface that I call closable, and the process will only close once both ends are closed. So once standard in is closed and standard out is closed. So we also, because technically we also have another pipe here, which is which goes to standard out here. But this pipe is like shared. So it's like it's this first pipe here. This is this S1 here. So that is actually shared. I mean, it depends on the fork context here, but in the last fork here, you can see we have S1, which is standard out. So it should just, an S1 is streamed in a separate fork as well. So that should always read from whatever's connected here and then output to standard out. And then once the cat standard out is done, then this pipe will close the source and not the destination, because well, actually, okay, this is the destination is well, it's not actually a pipe, it's more like a redirect, I guess, a redirect to standard out. Okay, I'm complicating things here maybe, but the way it works is basically the pipes are closing both ends, and once that is done, then the executable also like closes. But something happens at the last place. Get away. Where this gets stuck here. This is waiting for the executable to close, and somehow that doesn't work. That doesn't happen. So this pipe here needs to be streamed, which it is being streamed here. Maybe we should just create a fork for each pipe instead. Maybe that's more simple. Here's the pipeline compilation going on. There's a lot of things going on in here. But basically what's happening is, first we create pipes, and the number of pipes are pipeline stages -1. And we should probably now also then create sets for those to stream them through. I mean, technically we only need one set actually, because it's just the same set. It's like standard out. I don't know. No, maybe not. Okay, let's go through it again. So so here's the pipe we created, we fork it there. That seems to work. Like we stream S1. This is the pipe, this is the created pipe. So this is ref 0 or whatever. This is this ref here. So we're streaming that. And then this seems to wait. So this seems to actually just stream the data through. Let's enable the stream logs. Oh, we got an issue. Oh, yeah. Right, because we might have multiple sources. Okay, well, let's do a loop instead then. Okay, now we get all this information. So let's see, we can go down to the things. Right, if we look at this now we're at the first fork here. So this would fork to this thing, which then forks. So this thread will fork. This is where in this fork the executable will be called. Here we're trying to stream S1. Yeah, that forks again. So this is the executable fork. And this one now forks. This one now starts on the second stage. And now this pipe will start to stream S1. No source is connected, so that's fine. No source is connected. Yeah, because it's waiting for this to spawn, right? And now the main thread goes to sleep to wait for the other thread. You will still, no source is connected. This now executes the echo hello. And now you start on the thread that will spawn cat, which is this one. Okay, and here we can see the standard are actually closed for the echo hello, because echo hello is like, yeah, I don't need standard, so I close it directly. We're still streaming here. Now we can see, okay, we've got 6 bytes forwarded from echo hello. So it's like hello plus the new line. and you're still waiting there. Now you go to sleep, waiting for fork 7 there, and now fork 7 push. This still is streaming, but now the source ended the stream. So this stream is now done. You can see here also the poll is like poll in means that there's data to be read. So it's 0, so it means that there's no data to be read. Hang up, H up, hang up, it means that the source has closed. So there's no data and the source has closed. So that means we can just close it. And the echo now, since both, I mean every pipe here is closed, now echo is closed, and we actually execute like a wait on echo. Like in Zig, it's like a blocking instruction until echo is ready to be closed, which it is now. So, and you have to call it to get like its status, and we can see that it exited with success. Okay, so now this thread will end later, because now the wait should go through. Now we're executing cat. And we can see immediately here that we actually have destination, which we forward immediately here, because the destination was connected to the standard in of cat. We had data we can write to, and we forward 6 bytes. So now cat should write to its standard out. So we have to read from cat standard out. Yes. But we're still, yeah, we're waiting. Okay, so 5 ended, 7 still waits. Okay, so maybe that's what's missing. Yeah, if you look at threads now, echo was thread 4 and 5, so that's closed already. So now we're just waiting. Okay, so we're stuck here. So I think I need to look at what's happening here. The cat has a standard out file, right? Are we actually reading from that? It's like we have this exec instruction which spawns an executable, and yeah, so down here we create the init process, we set up the behaviors of the pipes, we spawn it, we assign our thread process to be the child, we get the pipes from the thread context, we say yeah, we create this process IO, closable process IO thing, which handles all the things. So this closable process IO is kind of magical, but it's like wrapping standard in, standard out, standard of the process in things that we can work with generically. And so standard in pipe from the thread context connects its destination to the standard in. So the process of the process. So the process now receives data from this standard in pipe, and it outputs data to standard out pipe and standard pipe. However, yeah, so that means that if we then call forward on this pipe, it should automatically read from cat here. But for some reason, that's not happening. Maybe we have to wait for spawn first. It might actually not be ready to receive data yet. I'm not sure. But that... I don't know. I'll just do this for a little bit. Okay, where are we now? Stream. Okay, main process is... Okay. Yeah, you can see here, this is echo because standard in is closed directly. Standard is also closed directly. Standard out is the one that's... Okay, there we go. Now we got forwarded bytes to standard out. Or I mean from echo to this pipe. And we haven't spawned cat yet. That one is closed. Okay, cool. So basically what happened in here is echo actually outputted its data, and we keep it in a buffer right now. So we have it in a buffer until and then we call cat. And once we call cat, we actually connect that pipe directly to cat standard in. And once we do that, everything in the buffer gets immediately outputted to cat. So here you can see now we connect destination to cat and we forward bytes directly here. And then technically now when we get to this part here, this stream S1 should pull that data out from cat and output to standard out. But it doesn't. Maybe we need to wait one more iteration, maybe. No? And it's like we can continue. Because what I'm thinking is like the issue is that we don't read from the actual cat standard out, but we are actually doing that because this closable standard out refers to the process standard out. So we are connecting the source of the main standard out pipe to that, and then we're churning through that. That should actually read from the process standard out, but it's something is not happening there. Maybe we'll do this. Maybe when we connect, we don't actually shove all the data through directly. Maybe we should wait with that. And we'll try to do that in the forward function instead. So what's happening is once the connection has been connected, or once the destination is connected, we flush the writer, yeah. We get all the buffered data from buffered writer, and we write it out all to the destination. And we also flush as well. So I'm thinking maybe we should do this at the start of every forward instead of doing it here, maybe. If we have a destination, I'm going to get all the buffer data. We're going to write all that out. I guess we could check like if buffered length is more than 0. We'll do this. Whoops. Byte forwarded from buffer. Okay, let's try that. Well, it says stream S1 null. So so stream S1 means that we are forwarding data with this pipe. So this pipe could be connected to a source and destination. So it's forwarding, it's basically taking data, reading data from the source and writing it to the destination. And S1 means standard out in this case. And the null means that it's just from where in the source code was this generated from, which null means it wasn't generated from any source. It's like the setup code. Or it was like generated from the compiler basically. So it's not tied to any line of code. Yeah. I should probably have a more descriptive thing there, but okay. So let's see if we can see here now. Let's forward a bit. So echo is created there. And now echo is exited. Cat is now created. And we're waiting. Oh, I see. I think I know what's going on now. So now there's no one streaming this stream anymore. This stream is like done. But that's not the case actually. That like we should actually, this should wait like the source was disconnected, the source was closed, but the destination wasn't open yet. So we should still keep this pipe. This pipe should still be streaming until cat is like now you can close. Because the echo is like this is done before we even get to opening cat. So this pipe is like, yeah. We need to keep it open somehow here. Maybe we should spawn the processes first before we create the pipes. No, but that doesn't work. We have to have the pipes before. Or maybe we should wait with the streaming then. We could set up all the pipes and all the executables first, and then in the main thread we will actually stream. No. Okay. No, but yeah. So then after we've spawned everything. No. Actually, okay, maybe this. Maybe in the last thread, the last stage. No, the problem is that we don't know if we've gotten to here yet. How would we solve this, actually? We could do maybe... no. The problem here is that... we want to kind of wait with this, closing this once before, like, or... yeah, we want to wait with closing this until the destination is connected. That's right. I think that's the issue. We don't wait. So we call forward, right? And if we have a destination, we do all this. But otherwise, we're like, we might not actually have a source. So if you don't have a source, and we get down here, and we're seeing that, hey, we don't have a source, so we're closed. And that's not the case, like, because we might not have a destination connected yet, which means we shouldn't be closed yet. I guess we could add like keep open, but then this will never close. That's the thing. We need it to close at some point. So I think what we'll do is here we'll check if we have a destination, then we return closed. Otherwise, we'll return not done. But that does that work? I mean, I guess. Also, I think here we'll do not done actually, because then we forwarded first the thing that was in the buffer, and then we're gonna try do a thing again. Yeah. there's so many things happening here, so it's like it's hard to keep track. It's really hard for all the edge cases and stuff in here. It's yeah, if we have a destination, we return close at this point. We could also wait until so this scenario is happening if the source connects without a destination, gets completed before we have a destination. So now we don't have a source and no destination, but then later the destination gets connected, and then we need to forward the buffer data and then close the thing, basically. Which would happen over here, I guess. But we don't want to... Yeah, actually, if we have buffer data and we don't have any sources, we are closed. We then close. Otherwise, we're not done. Because then we have sources as well. Okay. And then down here is like, okay, we don't have any sources left. Do we even get here now? Yes, we do. If we don't have a destination, we get down here. And but if we have a wait. No, we don't get down there. Yeah, we should just be not done here. Okay. Simplifying a little bit. Let's see if this works. So we're going through here. If we have no sources, we're not done. Or we have no source, I guess, as well. But if the sources were removed, but then this happens though. We're closed. Yeah, this happens as well. So here I think we need to check if we have a destination. So if destination, then we return close. Otherwise, we're not done. There we go. Or null. We could return null, I guess, maybe. Well, null means... I mean, it's the same thing. No. No, null means that we have more things. Yeah. Null means that we have more sources to process. Whereas if we return an event, that means this was the last source. Okay. Which means that here we're gonna say not done. Okay. It's very... a lot of things going on. What's now? Okay, so okay, if we have a destination and it's closed, we do that. We close the thing. If we have buffer data, we write that first. We also check if the sources are closed, then we close everything. Okay, and then the next time you would go in here, destination is not closed. Let's say we don't have buffer data, so we go down here and we might have sources. If we don't have sources, then we don't have sources. But if we do have sources, we go through and churn through those sources here as usual until they're depleted. Yeah. He says with confidence. Okay. Let's see now where we are. I wish I could add like a breakpoint for a specific instruction place. Like you can only add breakpoints at like source line numbers, but it would be nice to be able to add a breakpoint at a specific instruction, like compiled instruction place. Okay, so there's echo spawned, and echo is almost done. Now echo is exited. And now cat is spawned. Okay, they're still streaming. And there we go. Now this actually outputted things to cat. And echo is done. You're waiting. We're streaming standard in, streaming standard out. Now hopefully this would actually do something. No? God damn it. What the hell? Okay, this should now be closed. It's like it's done. It should be done now. Wait, standard in cat. Yeah, that's the destination. See, this stream should read from standard in, standard out cat and output it. So I don't understand why cat is not, why that's not happening. Like, was the pipe of cat not ready yet or something? Like, I don't understand. But okay, now the stream is actually open until cat actually closes its end. So that's good. So that is what we expect to happen. However, maybe it's because is cat waiting for something? I don't know. Maybe it's waiting for the pipe to close. But then this should happen here. Like we buffer this data, or we source this data through. This should be true. So then we should actually do close the destination here. Because this checks. This only does this. Okay. No. Yeah, this doesn't make sense. If sources is closed, that means we want to close the destination as well. Yeah. And now we can return closed. Okay. Yeah, because we're only in here if we actually have a destination. So there we go. There we go, that should work. Just like every other time that I said that. Okay, where are we now? Echo is spawned. We forward some bytes. Stand it out. We haven't spawned cat yet. Now echo is done. Cat is spawned. Standard in of cat is closed. And we forward buffer data. And source ended stream, closing standard out of cat. Cat should close at this point, I think. Or are we still waiting for standard error? No. Cat exited. Okay, standard error did close here. Good. Standard. So stream is one. No source connected. But it should have some data for us. And then we exit and we got some leaks. So, okay. Do we actually get it to standard out though? I don't think we actually see the standard out happening. Let's do like 2. What? Why is it hanging now? Alright, 2-step. See ya. We could also do, we could also say like this, and then we forward to output something. No. So we don't get anything from standard out. But it does complete. I'm just gonna fix this. Oh. Wait, what? Is there a race condition? You have a bug? You could say that. You could say the whole language is a bug right now. Alright, let's just fix this because it's annoying. Where is this happening here? Sources append, right? The source. Ah, okay. Where's the initialize? Oh, here we go. Self sources initialize. Oh, we're using like buffer writer allocator. Okay. Yeah, sure, why not? Actually, let's do this. Let's do allocator. Whoops. And then when we do, let's see, allocator. So here is self buffer writer allocator instead, which is good. Stream's good, don't change the layout, font is big, everyone is done terminal. Oh, thank you. Hate watching streams, cluttered mess, tiny unreadable text and tons of windows. Yeah, I mean, I couldn't work in that environment anyway. I need to be focused. And I'm basically trying to reduce as much clutter and stuff as possible. I still have some things here, like I don't really use this signs here. I could also remove that. It's nice sometimes, but it's like most of the time it's like unnecessary information. This bar down here I barely look at. It's like sometimes when I want to look at like the line number, I don't have lines here, so it's like useful for that. But I mainly like all this information is like it's not really necessary. This is like sort of good to have sometimes, but you know you can get that information as well. So it's I could probably just remove all of those things and have like a pure. But I guess it's nice for context sometimes, like as for streaming as well. You can see what the name of the file is as well. But yeah. But yeah, like if I introduce an error here, you can see I don't actually want to have a bunch of squiggly lines or text popping up while I'm writing. That is super annoying. Like that just takes focus direct, like immediately, and I'm like, okay, I need to fix this, like that's not the point. Like right now maybe I'm doing something else, and that kind of breaks my concentration. So I removed that from the config. And music is also interesting because every stream I go to has some kind of music, but it's also like, okay, well, What if you don't like the music that's on? You could add your own music. Like you can run your own music in the background or something. I'm just gonna get a cup of coffee here. Okay. Just have to do song requests so we can all take turns to suffer. Maybe I could add. Maybe I can have like the bot do something like that. Yeah. So like, the bot would. You would. I don't know. Run a command, but I don't want a bunch of those like spam. I don't know. All right. So what are we doing here? Yeah, the memory leak. Okay, yeah. Memory leak also. I need to fix, so the allocator is now the same allocator. Yeah. Yeah, this is now not that. This is buffer writer allocator. Which means everyone that's doing this should be not try anymore, and you, and then you are not a try, and you are not a try. Very good. All right. And you're not a try. And you're not a try. Okay. Do we still get this now? No. Great. So if we go to stream and disable logging, we go to process, disable logging, and we build, and we run. Why is it hanging now? That's weird. Okay, this might be a race condition. Yeah. Maybe. Yeah, see, now it exits. If I enable verbose, okay, see, there's some kind of race condition here. Request songs using points and a slightly higher price to skip the song. Okay. Yeah, I'm never gonna do anything like that. I mean, yeah, I don't know. Like, streaming is not my main. I mean, I don't like streaming. Doesn't get me a lot of income right now. I can say it's, you know, it's basically zero right now. I can kind of understand people who actually try to live off of streaming to have those kinds of things, maybe. But for me right now, it's not something I would do because I don't really need to. Because I work otherwise, so I have another income, so yeah. But I would like to go, like, if I could have streaming as a full-time job, that would be awesome. Or like, you know, content creation or whatever. Oblivion OST. For some reason gets my brain in the zone. Can't replicate with any other music. Oh, interesting. I think I used to have that, but right now I feel like if I put anything on, it's like distracting me. It's like I start to kind of drift off. I don't know. I get a lot more concentration if it's quiet. I mean, and then my brain is like, hey, put on like a YouTube video or something in the background, and then it's like sometimes it works, but most often I just get distracted by it. So I have to kind of work against my brain sometimes. Okay, well, this is disconcerting. Like there's a race condition. Okay, there we go. Now we get the race condition. We exit. Now let's open up this output file. And we are stuck. How many lines is this? Holy shit. Okay. Are you using LLVM? No. I'm using I'm using my own IR and it's interpreted. So I'm not compiling to machine code it. But okay, so what the hell? Yeah, look at how many lines this is. 1 million, 1.2 million. And the average bytes is like, I don't know, 20. So that will be like 20, like 40, 50 megabytes, right? $52 megabytes. Okay, anyway. So what is happening here is kind of hard to tell with the... Oh, shit. Why did I do that? No. Use AST? Yes. So first, I have a tokenizer, or lexer, that turns the source into tokens. And then I have a parser which turns the tokens into an AST, and then I have a compiler which compiles the AST to my IR language, and then I have an interpreter that runs those instructions. You're then not feeding that IR to LLVM. No, I don't use LLVM at all. I've never used LLVM, so I wouldn't know how to do that. I mean, it's an interpreted language. It could make sense maybe but if you want to have like a more efficient, okay, there we go. It churned through, okay, cool. If you want to have a more efficient, like you could compile kind of the bash, it's like compiling a bash script to a more, I guess, optimized version. But it's like the main focus of bash scripts is not performance. It's more like just doing some quick and dirty script that's supposed to solve some issue for you, to glue some stuff together. It's not like if you want to create like a fully optimized, you probably want to use something else, like a actual programming language that compiles. But since this is supposed to be just a scripting language, it's like you don't really need to compile to machine code. Okay, let's see what's happening here. So at first, holy shit. Here's the running part. You know what we'll do is we'll go down a bit. Okay, letting go of the controls. Let's go down. So now it seems pretty uniform. So I will pick somewhere here and delete that. But yeah, technically we could probably try to do this as an IR, or I mean as a to do like LLVM. But then the issue becomes like, okay, well, LLVM is kind of slow with its compilation. And you don't really want to. Well, it's slow with the compilation. Yeah, it's slow with the compilation. But then when you actually run the program, it's I guess it's fast. But yeah. Anyway, you get the point. Okay. So, what are we looking at? We are stuck at 4.2. So 4.2 is this part. We're streaming S1 still. Okay. So in some configuration of events, this pipe, which is this in-memory pipe here, never closes. Okay. So let's see what's happening with this pipe here. We are where is this? 1, 2, 3. Yeah, here we're creating the ref. Here we're creating the pipe. We're forking thread 4 here. And doing stuff. Here we're forking for the executable. And here we're forking the next, which is the cat stage. And then we start streaming. Right, so we haven't even spawned echo yet. So this should have no sources connected, no destination connected. And now this main is waiting there, right? This is still streaming, no source connected. We execute echo hello. Okay. And so destination connect. So standard in is connected to echo. Standard out is connected from echo and standard error as well. But this is a pipe actually. Yeah, it's connected to the pipe, right? Yeah. And then we fork. This is the cat executable fork. Then we, let's see, create that. Yeah, this is the cat fork here. Yeah, and then this is processed. What's happening here? Where are we? Stream S2. Oh yeah, because now, okay, yeah, because standard error now, it has two sources, right? Wait, no it doesn't. Or maybe it does. Yeah, it has... No, I don't know. Anyway. Right, this is still waiting here. Actually, now this is connected. Forward. Yeah, nothing's happening. Okay. This wait, push, stream. Stream. Yeah, S1 still has no source connected, right? Because cat hasn't been spawned yet. Now you're closed. Standard error is closed for echo hello. So echo hello now has standard in and standard error closed, which is normal. We're still streaming here. This actually now forwards some data. So this now, well, it's not forwarded, it's actually buffered. So stream is, because S1 is, or I mean the pipe here is has its source being closed, but then it also reads the data from it. And then it stores it in the buffer because it doesn't have a destination yet. I don't think. Unless I missed that. Okay, yeah, because now we execute cat here, which connects the things. And this is all connected here. Standard out pipe, standard or standard in. No. Yeah, the cat is connected to pipe, yes. Oh yeah, this is stream standard in, right? And then you have... So this is where it's kind of weird, because this should actually forward things now, if cat has data to read. No, it hasn't yet. We haven't streamed the pipe into cat yet, right? Stream S2 shouldn't do anything. Yeah. Here's stream S1. So this should now stream into cat standard in. There we go. Bytes forwarded, 6 bytes forwarded to hopefully cat standard in, right? Yeah, it says cat. Echo into cat. A bunch of waits. Stream S1, stream S2. So now we're just waiting for cat to output things. And S1 here, standard out, should be connected to cat. You can see here, it's connected to cat here. Why does it say 2 times though? Do we have 2 cats connected? That does not make sense. Cat reader into standard out. Yes, bytes forward 0, and then we stream as 2. And then we stream as 1, which should close at this point, I think. Yeah, echo should be closed. Yeah, ended stream, closing out of echo. Echo is closed. Standard in of cat is closed. So now standard in is closed, standard out is still open. Standard out. Wait, so cat actually exited. And hang up. No, wait. It didn't exit. It hung up. No, this is echo. Wait. Okay, I got lost here. Yeah, so echo is done here. Yeah. What is here? Cat out is done. Okay, so why are we hanging here? Cat should close at this point. Closing standard out. Okay, it's not actually closing cat because standard is still open, I guess. Source is hang up. Standard is disconnected. Where is this happening? Oh, now we're on 3, right? This is standard That closes standard So now cat should close. And we're waiting for it to terminate, and it terminated. Okay, so why are we stuck now? 5 closes there. This waits on the process, which should be closed now, so it should continue next time. 7, 6 are now closed. The main thread exits. We're still stuck on this one. No source connected. So the pipe never closes. That is strange. It should have closed whenever so this pipe is connected between echo out, cat in. Which is closing here. Echo. Hang on. What instruction is this? Stream as one. Okay. Echo out is closed. So that's closed. Okay. And then standard in of cat is also closing here. But the stream still says that it's not done. Okay. That's weird. So we have a destination. And it was not closed, I think. Oops. Up here, like when we check here, this is not closed yet. Yeah. So we're down here and we're doing the buffered thing, but we don't have anything in the buffer. So then we're going down here and we're looping through the sources to forward. Echo to cat, but it says that now we should close. So then we should be in here and we're doing this. And we're checking how many sources we have. If we have one source, we close everything. The thing is, though, yeah, and we also check if source is closed again. So that's the output here, but it's not closed yet. However, it is actually closed because it hung up. But that only happens when we try to read. So that happens down here in the stream, and then we get an end of stream, and then we say source ended stream. This happens. We should only have one source. So that should close the ends. So we should get there. Which causes these to close here. Which causes everything to close. And disconnect. Okay. And then we continue if we don't return an event, which we should. Yeah. So after that, we return this event. And the event should be closed. Because we do have a we don't have a destination because we close it and disconnect here. Okay. So I think we need a thing here like fully connected is equal to if self destination is not equal to null. if we were fully connected, then we close. If we weren't fully connected, that means we don't have a destination yet. Yeah, this is all very convoluted and very spaghetti and whatever, but got an error somewhere. Oh. Okay, I think that was the issue. Or maybe not. Okay, so now we're seeing, let's see, where are we? Stream S2. Oh, so now standing out is like it's closed. Wait, standard is not closing now? Okay, you know what? What I will do is I will add close source or close. So we'll close the source. Then, instead of checking if the length is 1, we'll check if all things are closed. Yeah. Because in the case of standard error, we actually have 2 sources. But they should disconnect though. Yeah, none of them disconnects. No, they should. Or maybe it's because they're not closed. Okay, whatever. Let's try this. I wish I could just go back and redo this entire pipe thing. I'll probably do that at some point. Okay, there we go. Except we don't know because it's like a race condition, so. Right. But the problem still remains that we don't get anything into standard out, so. Yeah. Let me just restart NeoVim because it seems to have trouble with. Actually, the whole OS here seems to have trouble. don't think we need process, but the streams, I do want to log out. Let's go into the debugger again. What the hell is this? No, IR2. Right. Where are we now? Source ended stream. What? Oh, yeah. Well, that's normal. Okay, so we got 6 bytes from hello. Great. Bunch of waits. Stream S1 is still open because, wait, source ended stream again? Or am I just confused? Okay, cat is spawned. Now we're connected with this to cat. And standard error as well. Stream S1. Now we're forwarding data to cat. Echo is done. We're waiting. Stream S1. Now, this should read from cat. Cat should have done something now to read from cat. It still says source ended stream. Wait, does that mean that cat ended without outputting anything? Yeah, no source connected, so cat is fully disconnected now. Everything ended and then we're done. Okay. So cat, so we are writing into cat standard in, but then when we read out from cat standard out, it doesn't actually provide any data and it just closes. So what is happening? What if we do this? This should be implicit, right? It's like the same thing. Bytes forwarded 6 to the buffer. Still not done. Good, good, good. Now cat is connected. It's spawned. It's connected. Yeah. So we don't have any data yet. So that is fine. But now we're forwarding data into cat. So it should have received the data now. And then cat just ends. It's... What the hell? Like, even if we close standard into cat, it should still output whatever data is left. Right? See? Okay, that's weird. If you... Okay, so if you type something and then Control D, which closes standard in, it actually, if you have, I guess if you have buffer data, it won't actually, it will actually output that. But if you Control D again, it will close standard in. Okay, that's interesting. So it's waiting for data. So we push some data in, right? And that gets flushed. So we are flashing. Okay. This is weird. I think I need more information. I'm gonna be 1 second, be right back. All right. Let's see. I'm gonna add some logs here to the process. What the hell did I do? There we go. I'm gonna do like whenever we try to get the close result of something here, I wanna post the state. I wanna log the state of this. And what we're gonna do is we are going to say we're gonna log this out here. Now where's the function? So get result. We will do that, and then here we're gonna say log. So parent logs state. There we go. And then do we need so and then in the process of checking that standard in, we'll actually do like a poll here, I think. Where is that happening? Standard in, yeah, this does a poll, but standard out we don't actually do a poll. But we could do that as well. We could do a poll for standard out to actually check if it's, yeah. Let's do that as well, and standard error as well. So first is like wait, closing? No. Here, get result. So this would be standard out term, but then standard out. But then we want to check, okay, well, if standard out, if we don't have a result yet, we're gonna check the poll as well. So we're gonna do standard out. We're polling. We're doing in here instead. Now it's not gonna be it's gonna be like if we have if in is 0, and if hang up is on. So if we don't have any data and we have hung up, then we should be success and return that. Okay, and then let's do the same for standard out, or I mean standard error. Oops. Forgot to change this. All right. Oops. Pull. All right. Okay, should we see what's happening now? Streaming, push, ref, wait, stream. Okay, here's spawning of echo. Fork, ref, wow. Do we have a circular dependency or something? It seems weird that we would get that. Because we're just calling poll here. That's the change we did. Okay, let's try this again. I'm not sure what happened there. So when is it happening? I think it was whenever it was spawned or something. No, now it's spawned. And then fork, ref, stream. Okay, stream says standard in. Oh. Right. So standard out. No. Okay, it's not here. It's actually, I forgot. We are trying to get result of the parent closable, which tries to log the state, which tries to get the state, which checks if these are closed, which in turn checks the parent. Okay. Okay, so let's not do that. Whoops. Push. There, it's spawned. Fork ref. now we're not dealing with that anymore. Standard error now has like 2 sources. This is kind of weird to me because we only spawn 1 process, so it should only have like 1 source. Or does it? Maybe I'm reading it wrong here. Because it's like listing echo 2 times. Although maybe it's like 2 different things. Yeah, it's forwarding and then checking closed. Okay. We forward some bytes. We wait, push. Nothing happens. Now source is closed. Well, it was closed before. I mean, this one still open. Okay. Wait. Spawn cat. Connect stuff. Stream standard in, nothing happens. Stream standard out. Still nothing happening here. Okay, well, I think that's expected actually. And cat just exits straight up. Wait, what? We haven't even... Standard out is still not... What? Wait, what? Oh, now we're not... We haven't forwarded the data though. Why is standard in closed already for cat? I don't understand. Oh, we buffer the data and then we close standard in. Maybe we have to wait for that then. Maybe we don't actually close the standard in. Maybe we wait for the process to close it. Okay. Let's do that. So stream, no, compiler, no, wait, yes, wait, no, wait, pipeline, where are the pipes? Here's the pipes. So I think we don't close standard in or close destination. Let's try that. Echo spawns. We'll read from echo standard out. Cat spawns. We're forwarding into cat. Wait for the process, wait. Nothing still from cat. Stream is done. Okay, I guess that's fine. But cat still doesn't output anything. And now we're stuck here. Echo spawned. Where is cat? Cat spawns. Okay. Nothing, nothing. We forward to cat standard in. It accepts some data. And now this stream is like the source is closed. But the destination is still open, I guess. And that's it. That's where we get stuck. So it's like cat just takes the data, just swallows it, and then does nothing. But thread 4 should not actually sleep at this point. I think. Yeah, okay. The stream should not like close until the destination closes. So I think we also say disconnect destination is false. We should keep the destination connected and wait for it to close before we close the stream. Okay. Right, we're still streaming here. Cat is spawned. Now we're forwarding data into cat. Waiting. No. Why did it go? Why is the stream closing? So we have a destination. The destination is not closed. We had buffer data, so we write it out and we're checking if the sources are closed, which they should be, I think. And then we also do this. And then we return closed. Right. But I think we should only do it if we don't want to disconnect or close the destination. So I think what we do is we check first if is destination closed, then we return closed. yeah. The amount of times I'm like, yeah, this should work, and then it's like, yeah, there's still a whole bunch of stuff left, because it's so many things going on. And it's hard to keep everything in your head. Cat now spawned. We forward data into cat. Yes. Now we're still stuck on stream. This is good. Still stuck here. We're waiting. Okay, so now we're kind of waiting for cat to close its standard in. But that doesn't make sense. We should be the one closing standard in, because then cat doesn't know if it's supposed to close it or not. Yeah, that doesn't make sense. We should be the one closing it. Maybe we close it too early or something. I don't know. But we flushed data into cat and we still don't get anything out. Yeah, this is no. So actually we do want to close the destination. Yeah, and now that happens. We forward data into cat, and then we also close standard in. And now cat is like, hey, now I'm closing. Why is cat closing is the question now, because standard out is still not closed, standard error is still not closed. This is wrong. And probably why now everything is messed up. Why did it close? Standard in close. Closing standard in. This is closing the actual file, I think, yeah. And then it does this, and then it's like determining, hey, we should actually close now. That doesn't make sense. Oh, because the act of checking is closed is now closing the thing, right? Or well, it's storing the term. So cat closes its standard out like immediately. Right, it outputs the data. So it receives the data, it outputs it, and then closes immediately. When standard in is closed, it doesn't have anything in the buffer, I guess it just closes. I mean, I guess that's fine. It's just that we don't see any data coming out. Here. Cat is closed now. But we haven't read from standard out yet. We've only pushed standard like data to standard in. And closing cat will perhaps close the files as well. No, this is still connected here, but we don't get any data. Okay, and then I guess it actually just thread 5 is waiting for the process. So this is echo. No way. Yeah, this is echo. What the hell? I think. Yeah, 1, 2, 3 is standard. 4, 5 is echo. Is echo not closed? What the hell is happening? Echo. Forward. Cat. Okay. Streaming S1 closes the destination, yes. Which should now close the stream as well. So then we wait for the process, which is number 5. Okay, so it goes to sleep, right? It's waiting for echo to exit. But it should have exited already. So we don't have a destination, so we're going down here. We should have a source. We're going through the sources. We're forwarding. We get an end of stream next iteration. We close the source. That should happen. It could be that we actually get the destination before we close the thing. And then we do this. And we check if sources is closed. We close. Destination, disconnect. Okay, maybe we should disconnect the source as well. But then next time it should go in. No, but then the source is not closed though. So then it should like it returns not done. Next time it doesn't have buffer data. Destination is not closed, so it should get out here and go through here. And now end of stream is true, so we should close it, right? Or it's already closed, so we just remove it. Like, in what situation would that happen? Push. Here's it spawned. Now the bytes are forwarded, so we store it in the buffer. At this point, the source should be closed. Why is it not saying it's closed? That's the issue here now. It should say that it's closed now, but it doesn't. And this should log the poll, right? No, it's not. Okay, we're not logging the poll. Okay, let's log the poll so we can see what's happening. Wait, why is that? Okay. Right. Oh, there we go. Or what's happening? Expect the expression or return. Ah, there we go. Okay, and I guess we'll remove these because we're logging it out in the function now instead. So here we go. Yeah. All Cool. Now we should get more logs from that poll thing. Push spawn. And we can see also, yeah, so here you can see that, wait, why does it say 10? Wouldn't that be just 2 then? No, it's hex, right? It's hex. Oh yeah, maybe I should have. Maybe it should be binary, actually. Okay. Well, anyway. Forwarding bytes. Yes, very good. So next time around, we should now be closing. And here we can see that for some reason we get like result null, but we do log out the hang up here. So it says that it's closed. That's standard out of cat. Standard in. Standard out. Okay. Exited, yeah. That's the destination. What about the source? It's over here, I think. No, we're not checking source. We're just forwarding, and then we're not done. Right. Yeah. I think. Wait. No, stream. So we're up here, we have things we forwarded. We check if sources is closed, and then we close. So why is that not happening? Let's go through this. So this is the destination check. This is this up here. And then we go down here and we write out, and then we check if sources is closed. Byte forwarded. Here's the check. If source is closed, why does it say standard in? Whoops, it is. That was wrong. Wait. We're forward. And then we close. This doesn't make any sense. We close the destination. This should log here. This should log out something here. Because we're checking if it's closed. Why is that not logging out? And the source is the closable reader, standard out of echo. We should be like, it should call this. But it's like it's skipping that and going straight here. And this returns true as well. So was it disconnected? Maybe. Yeah, maybe it was disconnected actually. Okay, let's go through this again. Bytes forwarded. Yeah, we have data and we're done. So that should not disconnect at this point. Next time around, it should disconnect here though, I think. Because now it's closed, yeah. But we're not really saying that it got disconnected. So we don't have a destination yet. We go through, we check if it's closed, which it is, then we remove it. Right, so we do disconnect here. And we continue, yeah. And then we get down here, we disconnect the sources. Yeah, but we don't close. But that should happen anyway. That should happen in here. So if we don't have a thing, we check first if we are closed. If we are closed, then we set our close thing to success, which kind of sets the state of being closed. So at this point, the pipe should not have any sources connected. I think. Yeah, it's supposed to be disconnected here. And then now you're connected. And we forwarded that. Right, so it makes sense. If we don't have any sources connected, this does make sense. Now it's trying to close standard in of cat, and it does. It closes it. It checks if we need to close the parent. And it looks like we should not close the parent, because standard out is still active. However, no, yeah, okay. But then all of a sudden, cat closes standard out. Like we're polling here to see that, okay, well, it's not, it's, no wait, that's standard error, right? Standard error is closed, right? Here we're polling and we're seeing that, hey, we don't have data and we haven't hung up yet. Okay. And then we're polling again. Now it's like, yeah, sorry, I hang up. Okay, well, where's the data? Okay. And then this is already done. And then we close cat. I mean, yeah. And then this should be closed by this point. We get success. You get success. That ends. You should end later. This still waits for echo for some reason. Main thread exits. Now we're stuck on echo. Maybe we'll add some more logs to see what's happening here. Source is closed, removing source. Source, so this is called twice. This is concerning because calling source is actually an act of, it's actually a side effect now. So I'm gonna say source results. Yeah, this is hard to kind of think about what's happening here. Because we're polling and checking, oh, so you have no data to read, and you've hung up. Okay, fine, then you're closed. But we still want to forward maybe something. I don't know. It seems weird. It seems that we should be able to do that, yeah. But anyway, so do we need more logs? Let's say here we log Norse, all sources closed. Closing destination. Both ends closed, closing stream. Destination closed, closing stream. unless we want to keep it open, but keeping open. I'm not sure if this scenario is even happening, but yeah. Okay. Could also have this be logged as well. Sources closed. Closing ends. Keeping open. Closing stream. Thank you, piano. Alright, echo spawns. Let's see if we can remember what's happening here. Oh, we got broken pipe. Oh yeah, that makes sense. Yeah, we got broken pipe. Echo always breaks the pipe of standard in. I guess unless you pass some argument to it. Okay, here we see standard error, closing source, source is closed, removing source. Makes sense. Here's this one. We get 6 bytes from the source, but then we continue. Okay, let's see what's happening next time around here. So still source is closed, removing source. Why is it not removed? It should have been removed before, so that okay. Now cat is spawned. Okay. And here now a lot of things happening. So forwarding the pipe between echo hello and cat. So cat says that hey, I can accept data. We forward bytes into cat, standard in, and then this says that hey, all sources are closed. So now we close the destination. Closing standard in of cat. We have forwarded the data, but we're closing it immediately after. Which makes sense, right? And then we have check close parent. Yeah, so it's checking if we should close cat, which is true at this point. So cat actually exits. Okay. I don't think at this point we have actually had time to actually read from cat standard out. we forward the data and cat automatically exits, but do we still have the pipe? See? Now standard out says that cat exited with 0, and so we're removing that source. But we should have a destination. Destination is not closed. So we should be over here, and we should be forwarding the data, which we're not. No, wait, maybe no. It should have been. It should have been forwarded directly to. Wait. Cat standard out. No, we need to read from it. Yeah, we need to read from it. So we never got the chance to read from. But this should not be closed. So we should be going over here. This is 0. So we should be going over here. And we should be reading from the source. However, this is closed. So then we actually just remove it. Okay, we never read from it. We should read from it one more time. Oh man. Maybe this is an issue here that we close standard in immediately. We buffer data. Yeah, maybe we should just not do this here. We just buffer the data and then we say, hey, we're done. Okay. Next up, we go through and we check we forward the data. How do we know that we should close the destination at this point? Because we don't have any sources maybe left. This is a conundrum. You do that, piano. Thanks for stopping by. So we've got like source connected, source streams data, well, let's call this stream reads source and buffers data into the buffer, and then source disconnects. So now at this point we have we have the pipe. Let's call this the pipe. The pipe reads the source. We buffer the data because we don't have a destination to forward it to. The source disconnects. And then the destination connects, the pipe writes buffered data, and at this point it's like we should also close the pipe. But if we continue, how would we know now that we should close the pipe? It's like we have a destination with no source connected. I guess if we have it, as soon as we get a destination and we don't have a source, maybe we should just close the thing, unless we want to keep it open. So okay, let's do this. If we have a destination and if we want to keep open, we're gonna say no source, otherwise we'll close it. And we also we need to close the destination. So close destination. Disconnect destination. I think adding commands would be fun, could increase interaction. Coffee, tea. Here's a fresh cup. Okay. Yeah, sure. I'll see what I can do. So we close those things. Destination, you open. But if we don't have, we do no source. Okay, so if we don't have sources, but we do have a destination, that kind of means that we should close, unless we have keep open, which is true for all the, like the actual standard in, standard out, standard error. So they will never close. They will just say, hey, I don't have a source. If we don't have a destination yet, that means we haven't connected a destination yet. So then we also say no source. But if we do have a destination and we don't want to keep it open, then that means that basically we need to close this, because now we have a destination, we have no source left. So then we just close. And we don't close over here. We're saying, hey, we're not done yet. Let's try that. Yeah, I see what you mean. Yeah, like it's a nice suggestion. Like I don't have a clue what to put there because I've never been in that world. Like I don't really engage in chat. Like if I go and watch a stream, I don't really engage with the chat, so I wouldn't really know what to put there, but I'll try to figure something out. Okay, that's standard in, it's close, it's broken, yeah. So it removed the destination, good. Standard error closes the source, great. This stream forwards some bytes. Great. Standard in is now inactive, basically. Standard out inactive, standard error inactive. This thing says that it's removing the source. Okay, good. But it doesn't have a destination, so it has buffer data. And now cat is spawned, it's connected. So now next time, so standard in is inactive, standard out now is connected to cat. Okay, standard error is connected to cat. And this stream now forwards some bytes, and then it's like, okay, we'll forward bytes and then we'll see what happens. So now these things are waiting. Standard in does that. Standard out. Okay, I would expect standard out to actually receive data from cat now, but for some reason that doesn't happen. I don't know why. Standard error. This thing now quits, which is expected. Standard in of cat is closed. We have forwarded into standard in of cat. Maybe that's what's wrong. Maybe that doesn't work. It should work, but maybe something is wrong there. Yeah, maybe I should like add writer traces, but it should work. But anyway, these things are nothing. Standard in is closed. Then we're checking. Okay, standard out is apparently doesn't have any data and it hangs up. Doesn't make sense. What am I missing here? Cat should output the data it got in. Ah! And now cat is closed, so this closes here. I mean, this is kind of efficient, like cat is closed as soon as we input data to cat. It's basically closing almost. But then this is wait. Okay. Yeah, echo never also echo never closes. That's also a weird thing. Oh, what the hell? I already had a thing going here. Yeah, sorry. I'm getting a bit frustrated because I've been sitting with this issue a long time now. Okay. What do we need to do? So I want to check if there could be something wrong with writing to cat standard in, if that actually writes to cat standard in, or if it does something else. I could also put up, create like a fake scenario or like a minimal example of actually calling cat. So we have this poll standard in example here, where we actually have like an example we could use to get some information about what is happening when we actually spawn cat. So let's say we spawn cat here, and once it's spawned we can put some data into standard in, and then we would try to read from standard out. But I think what we need to do is I want to do cat So let's do this. And everything is pipe, yes. We're reading from standard in. We don't really need to do that though. We can say, we can do this. And then we don't really need to do anything here. Actually, what we do is, I'm gonna delete all this. What I want to check is just saying, I just want to write to this file. No, child standard in writer, and let's have like standard in buffer. Okay, so that's the writer, and I will have standard out reader. Okay. Now what we'll do is we will write some data. Hello. Let's do the exact example that we have. And then we will do flush, because that's what we're doing as well. I hope. Yeah, I'm pretty sure we do. And then we are going to close this immediately. So we're going to close this file immediately after. That's what we're doing as well. And then now we will read from standard out. We could stream actually. Stream into, and then let's get like the actual standard out, I guess. Okay. Sure, let's do this. Let's stream to this and we'll do catch, because we could get end of stream, in which case we break. We can also log the events here. Actually, you know what? Let's not do standard out. Let's actually do some kind of allocating buffer. Right. So now this would be writer. And then I think you return like bytes read or something. Yeah. So end of stream, we would do log, and we would say end of stream and break, and then we would result is going to be whatever's written in here. Okay, now bytes read. Every time we read some bytes, we're gonna say bytes read here, and then we can also say current result is this. Oh yeah, we need to switch on error as well. There we go. And then we have else. If we got any other error, that means that we actually got some weird error thing. So I'm just gonna return error here. Okay. Standard error is not used. Let's actually. What do we do with standard error? I guess to make it like a full example, we'll do this. Oh, we don't need the buffers actually. There we go. This needs to be address. Zero standard error. All right. And we can prefix this with standard out. Standard error. And out, bytes read, standard error, bytes read, whoops, now we do standard error. I think it's like if we have bytes read, we write it. Because we might get spammed otherwise, I'm not sure. Standard error bytes read. Whoops. Alright, standard error. Standard out. And standard out result, standard error result. All right. So I think this kind of mimics what we're doing. Standard in, we don't need a writer for standard in, I think. No, we do. Oh yeah, this needs to be that. Okay, there we go. We got there. Now, let's run cat. All right. Are you a try as well? Yes. Do we have anything else? I don't think so. No. Whoops. 49 expected bool, 5 year size. Oh yeah, if it's more than 0. Whoops. Okay. Okay, so it should work, as you can see here. That's good. That's very good. Although it says like end of stream. Okay, we shouldn't actually break. We should do like standard out ended false. Is that really the issue? No? Oh. Wait, what? Oh, I see. I guess this would be like 0. We need to kind of have this label here. Or here? Maybe? Still not entirely sure about these labels, apparently. Break 0. There we go. Because the problem was that this needs to be set to some result. And since we didn't return anything here, it was like a void type. But now we added a label here so that we break 0 out of this whole switch expression, which in the case of a catch will now set this to 0. Okay, there we go. So now we got like end of stream bytes read 6. Standard error is like immediately ended, and then we read this, and then we got end of stream the next. Okay. So that is what's expected, which is good because that's kind of what we're trying to do. Like we write it in, we flush, we close standard in directly. So there's no problem in doing that. That's good to know. And then we're also reading from the standard out, which should also work. So not sure why things are not happening as they should. So what can we test now? We can test enabling the logs for the trace writers. That will give us more information about what's going on with the writing. Push. Now we're executing. So now this is executed. Stream. You read data. Good. So now we buffer the data. Source is disconnected. We're spawning up cat. Nothing is read from cat yet. Now we're writing into cat standard in. but we don't have traces here. So I could oh yeah, we do have trace. We'll see here, drain. Right. We're draining, but we're not draining anything. Oh, that was from the flush. Okay. But this didn't actually do anything here. So the destination does not have trace on its thing. Right. Because this buffered. We do have a trace writer, but I don't think we're using it. The idea is that this would wrap. Yeah, this is wrapping the buffered writer, and then we want to use that instead. When we, yeah, but we do, wait, we do that. If we have a destination, otherwise we return that, but then what the hell is happening here? But this isn't, I don't think this is like used. Or maybe it is actually. No, but this is logged anyway. Oh, let's log this. Let's do that. There we go. Echo spawned. Standard in is closed. Standard is closed. Standard out gives us data. Very good. And now source is closed. We remove the source. We spawn up cat. Nothing's happening here. Now you are forwarding data into there. But we don't really see anything happening. It says that it bytes forwarded buffer data into cat standard in. But and we have a destination, so it should be connected. This is where it's happening. We're doing the poll, which is this poll you see here, right? Or actually it's this poll we call drain. on something else, but this is like, I'm not sure where this drain is coming from actually. Okay, so we're flushing basically 0 bytes. But we're doing a poll and then we're forwarding back. Yeah, that happens before, yeah. So we get here and we see that we have out. So we should be writing this thing here. But then we don't really see what's happening here. This file writer interface, yeah, because this file writer doesn't really, it's not tracing what's happening. So maybe we should add a tracer here to see what's actually happening. Trace file writer is a trace writer. So this is its own writer. Yeah. So we'll have this there. Buffer writer label, yeah. So we actually can't use this yet. So we'll set you to undefined for now. And then during connect, we will say trace writer, it's gonna be init, and then we need a buffer. The writer is this whole shebang. Oh, excuse me. And then this was, I don't know, the label is like standard in, process standard in somehow, some kind of label there. Yeah, we need this now. Standard in trace buffer. All right. Now, wait, do you need anything else actually? No, I don't think so. Now where's the pipe thing? Pipe writer. So it's like, okay, now we should have a pipe writer, and we should, or I mean a trace file writer, which should be the writer that we're supposed to use. So instead of doing file writer here, what I'm gonna do is I'm gonna say if this is null, we return 0. We're gonna set file writer to be self or parent trace file writer, and then writer. So that is, well, this is the writer actually. So you would be the writer dot write splash. There we go. Okay, so hopefully now we will get more information here about what's happening when cat standard in gets written to. Where's echo? There we are. Echo standard in closed. Good. Standard error is closed. Good. We read from standard out of echo. And then nothing's gonna happen until we open cat here. And here we should see things now, hopefully. I don't see much. What's happening here? We got the pole. Here's the drain of nothing. We get the pole here, and we get nothing. I'm pretty sure this is what's happening. We're polling and then we're writing to this. So why are we not seeing any output? That's what I want to know. So maybe we're not even in here actually. But that's what I was thinking that we were. We could also log here, I guess. Else if return error parent. Let's echo. Cat. There's cat. Yeah, look, this is it. It is actually in there. But it just does the poll and then ends. And then it says like, yeah, you got 6 bytes. What the hell? So we do this poll. Because if we actually got in here, this would be like the trace writer, and then we would get some tracing on there. Okay, well, let's do... Let's do like poll. Self. Speed running. Cat spawns. Here it is. Yeah, see? Poll 4. Yeah, that's what we're getting here. We already saw that. So that means that we can write to it. And it's open. So why is that? Okay. We should go in here. Did it bash it correctly? I'm just gonna BRB 1 second here. Alright. Let's figure this out. Where are we ending up? Polar. pull out, pull it up, or and back. Wait, are we already there? No, we're not. That's the first one. There we go. Yeah, so what the hell? Okay. So we do that, but it's not writing anything to the thing. It's not like the trace writer. Okay, also let's do this. Let's do trace writer drain. Now we should see what is the data there. Did remember add the correct file extension to write the template to the file. Sorry, are you like an AI or something? I don't understand what you're trying to say. Cat. And now it should happen. Boom. Okay. Okay, look at this. 6. It's going into pull out. Why are we not seeing any trace writing? I don't understand. I do not understand. It's going in here, it's returning this. This should go. Wait a minute. Shouldn't we flush as well? Oh my god. No, but we're flushing after, right? No, this should just flush it through, I think. But we're writing to... You know what? We're gonna implement flush. Your keyboard is messing up. 20 minutes. I'll probably quit here pretty soon. I'll try to fix this issue here, and then hopefully pipelines will work. Okay. Flush. Yeah, flush should just forward the flush to. So what? Okay, let's look at flush here. Actually, we can look at TraceWriter. Flush. That just calls default flush though. But what about drain? Drain actually does flush. Yeah. So let's do that. Let's not implement flush. Let's do after we write, we also flush. Okay, that might have been the issue all along. Holy crap. So many issues with this, but okay. Was this built? Yes. Let's quit in case. Just in case. Speedrunning. Ah! Alright, binds forwarded. Cat is spawned. Flush. Okay, the TraceWriter now says flush. It's draining. 0 bytes. Why is it 0 bytes? Also, why doesn't write flat splat work? I think it puts it in the buffer first, which should be the buffer of the parent. But then it should just write that out. Do you work as a web dev or zig dev? Web dev. I'm gonna get more coffee here, BRB. All right. Okay, what's happening in here? So if it does not fit in the buffer, we drain it. If otherwise, which it should fit, so then we will copy that over to the buffer. Yeah, that's what I thought. Like, it doesn't actually go into, it doesn't output anything because it doesn't go into the actual like implementation functions of write splat. However, when we flush, it should write that out. So that's, and now I'm confused why it's not doing that. Echo spawns. Cat spawns now. We get this here. 6 bytes. We check standard in of cat. Which we, in between here, we actually write to it. But when we flush, we get nothing out. So I don't understand that. What's happening there? Like, it just swallows the bytes. Okay. We get here. We write, it actually says, we actually get 6 back from this, because then that gets returned, and we can see that this actually returns 6. Right? It's not doing this, because that would have, we would have gotten that message. It could be doing this. Well, it is doing this, because it has to go down here. Pattern. What the hell is this? What is this magic? Pattern. Data length -1. So that is like the last data. Yeah, okay. Oh, okay, that's the splat thing. So it's like it's getting the pattern, yeah, the last thing, and then repeating it splat number of times. here we're looping through all the strings except for the last one. Okay. And then when we're at the last one, we grab it out, and if we have some optimization here. If it's larger than 1, which it is, it's 6, then we copy it in a loop here. Okay. So that's what's happening. And then we return count, which we count here. So it is stored in the buffer. Okay, and then we flush. So that should call flush, which should call default flush, which just drains until we're done. Right, and drain actually has a special thing where it should actually look at the buffer first, which we don't actually do here. If you look at the documentation here, is that buffer should be consumed first. So let's do that actually. We get the writer, the data. So actually we're gonna say if we have buffered we want to write yeah, let's do write this no, we write that yes. So if we have a buffer, we write the buffer first. Then we actually need to consume that. So we'll do consume all. No, consume bytes written. No. Yes, I mean. And then otherwise we write the splat, consume that number of things, and we don't consume, but this is where we don't have anything in buffer, so we can't consume. Here we flush the writer, very good, and then we return bytes written. Okay. So now we're doing the buffer thing. I'm just gonna double check if we're doing that on the trace writer as well. I see, we are doing that, except in a different way. Consume, what is this? Removes, returning how many bytes are left? I don't care about that. Okay. What will happen now? Echo spawns. cat spawns. Okay. Like, I don't actually know what's going on here. Standard out. Oh! Standard out actually has data now. What? And it's closed, so it closes. Okay. What the hell? So next time around we go. Now, should we get it? Do we get it? So it says that it has data and it also is closing. But why do we not get data? Okay, standard is closed. Fine. There we go. There's our little hello. Oh my god. Okay, so the fault was like a bad implementation of the writer, basically. And we should exit at some point. What's happening now? This is waiting for echo. So okay, we still have an issue with these processes. They are not actually like exiting. But okay, at least we got the actual data through. Yeah, finally. Okay. Now, yeah, okay, so the executables, they are not closing there. So what is happening there? Where is standard out? Or I mean echo. Where's echo at? There's echo. So in order for the executable to close, standard in and standard out has, or standard in, standard out has to close for it. So standard in here closes immediately. I think I know what's going on actually. I think I know. So basically, normally we would call close. However, we would call close standard in, but I don't think we're doing that because we're calling get results, which kind of closes by itself. I think actually if this is, whenever we're like trying to do this, we should also check the parent here. Yeah. And same for standard in. Alright, because that will close the whole thing. Yeah, this is a very spaghetti here, but we have to deal with it. Okay, there's echo. And you can see standard in closed, standard error closed. And it's still open. But now echo exits because now we're checking everything. So now, there we go. And we should soon be done. There we go. Oh my god. Okay. Let's go. Let's go here and disable all the things. All the whoops. Trace writer. Okay. Let's open up build. Now we'll just run it and see. Hey! Finally! Oh my god. Also, I want to try this. Yeah. Cool. Okay. Now let's see if we do this. We get a whole bunch of hellos. I just have to kind of, okay, that was a huge chapter that just closed. And now my brain is kind of unloading. Okay, great. So pipe. So okay, let's try double. Let's try if we can have multiple things, because this is not the exact same scenario. Okay, it still works. Good. So let's say we do like. Yeah. Okay. Oh my god. It works. It's alive. Awesome. And how big is this program? 79 bytes of read-only data. I wish I could see how many instructions we have, but basically it's not going to be that much. 13 in the main, 3 in the pipes, and then we have a bunch of sets here of 4. Yeah, not that much, but I mean, and then the execution is like, I don't know how many lines we're executing here, but yeah, cool. Now, what if we say, error flag? So this will be some kind of error. Oh no, maybe not. What if we do this? No? How do you pass flags to echo? Long option. Like, how do you make echo error is what I'm trying to figure out. Okay, enable interpretation of backslash escapes. What if we do like echo like, I don't know, M. Oh. Okay. How do you make echo error? I mean, I could just pick some other thing. How to make echo error? No, that's not what I want. God damn it. I mean, cat, I think if you do like... Yeah, there we go. That should be an error, right? Yeah. So if we do that, because that's what I'm trying to do here. I'm trying to make an error happen. So okay. I don't think this works yet. We don't have bindings, so this would still. Yeah, this. Okay. It works even worse. Man, what am I trying to do here? I think like if we do like echo hello, what does that actually do? It does echo the hello. It still like spawns up echo. Okay, now comes a real test. Does that work here as well? Kinda. Okay, so here we can see the difference between Bash and Runic. A little difference at least. We might change this later, but we actually spawn these in sequence. First this one and then this one. I think Bash does the opposite, I guess. Which is fine. I mean, it's not as good as doing my way. No. It's probably better for some reason. But it does kind of do the same thing. Although I would argue... Well, maybe this does make... No. I would argue that this makes more sense from a user perspective, because you would assume that this happens first and then this, you know? I don't know. Maybe it doesn't matter that much. It's kind of a weird example anyway, maybe. But I'm just trying to test these pipes out and see how it should work. My idea here was that, yeah, the result of the pipeline should be the exit code of whatever is first, like, outputted. So that's how it works. Like, if you run this in... If you run this like in the normal Runic world, oh, we actually get this. But if you bind it, you don't get anything. But if we say echo exit code, we should get, what the hell? Is it because echo actually succeeds? Did I implement this? No. No squared. Okay, interesting. But if we do this, we should get some weird exit code, yeah. So anyway, okay, awesome. So we have pipelines working now, sort of, like at least the most basic pipelines here in the IR version. Awesome. So, what is the next step? Basic pipelines works. Pipelines sort of works. We have this. There's no like error handling though. Yeah, we'll figure it out. Error handling, I'll put this here. And we also have like, you know, the ampersand. I mean, we do have virtual threads. Yeah. Evaluator, we do have threads. Yes. Execution results. No, materialize string. Debugger. Alright. So, what else can we do? So, next step is what? I think I want to kind of do this thing here is like right now pipes are actually we're kind of cheating with the pipes. So if we go and look at IR value, now the idea with these values from the start was to have them be fully serializable, so that you could, for example, you could refer to a pipe with some kind of handle, or a closable with a handle, which now closables is the only thing we have for that right now is threads, or not threads, what is it, processes. Yeah, that's right. So process, so this is basically like a process handle right now, and this is like a pipe handle. However, it's not serializable because we're using the actual pointer here to the actual value in the runtime. So, and the same for closable. So what I want to do is change these to be handles instead, that we can then refer to instead of referring to like the actual value here. But in order to do that, we would have to have some kind of runtime context that keeps track of all that. So that would have to be in the evaluator. Where we have right now the context. So it would be here somewhere. So we have a bunch of thread stuff. We could add, you know, pipe handles or pipes, which would be a map from, you know, a pipe handle to a reader-writer stream. So that's the pipes, and then we have closables, same thing, except this is a closable handle, and this is a closable exit code. No. All right, so now we have the places to have those things. And we could add some stuff. So we could add a new pipe, or add pipe or something. And we don't really need, well, I guess we could have a configuration for it. And then some kind of error. So try pipes. Actually, also what we need is pipe handle counter and a closable handle counter. You know what, these handles, I'm just gonna say, well, it's kind of like, it's good to see what it is, but it's basically just gonna be U sizes. Oops. And so the handle is gonna be self pipe handle counter, and then pipe handle counter is gonna be plus equal to 1. Okay, and then this one we put the handle, and here we're doing stream u8 init reader writer. And you need an allocator, a label. I guess we can get the label in here as well. Okay, and then we return the pipe handle out so that we can use it. So this would be the handle. Yeah. Now that's like a runtime value now. So it's like it's runtime known. Okay. And then we have the same for closable. However, the closable, we probably want to just grab out this because it's going to be hard to actually initialize it here. We have to kind of get it from outside. So actually, you know what? It could be the same here actually. Whatever. We got the closable handle. This is an exit code. Handle is closable handle counter. This is closables, but handle, and then this is actually closable. So actually you are a pointer. Well, yes, you are already. Okay. That's right. You need to do that. Okay. And then we return the handle. Now we need also functions to get the pipe. Which gives us a reader writer stream. So we'll return pipes get handle. And I guess we have to have it, so I will unwrap this here. I mean, have to is a, but we're not gonna have like the optional, like in the instructions, we're not gonna be able to check this, I don't think. Get closable, same thing here, closable, this is a closable handle, and this is closables, there we go. So now we can store them in there, and we can do that. Now the value, this is gonna be, let's just say use size here, I don't wanna deal with it. And now you're complaining here because we don't actually have access to this anymore. Which is fine. I mean, okay, we do have the handle. Same for pipe. That's actually helpful. Of course, print. Right. So, what is this now? I think what we need to do is we need to add instructions to actually create these things now. Because for threads, we have the instruction called fork, which creates a thread, but the thread ID is actually runtime known. And then you can store the result in an optional like location. So I think we need the same thing, except we need it to be for pipes and for closables. Well, closables we kind of already have with exec, but for pipes we don't really have a way to. We don't have a way to create a pipe. So I'm gonna say pipe. And this creates a pipe and stores its handle in the given location. Okay, that's the instruction. Okay, so instead of doing set, we will do pipe that we don't have. And the pipe needs a location to store it in. And this is pipe, which is just a location. There we go. Okay, so now you actually, we don't. Oh, wait. What about the config? We need a config as well. Disconnect destination. Oh. Is that relevant anymore? Hang on. If you pipe into cat is done. No, I think it's not relevant anymore, I hope. Let's try and just forget that this ever was here. There we go. Cool. No field name location. Oh yeah, results, that's right. Okay. And these pipes now are handles. So, okay, this actually is interesting because the compiler now, in like forward standard IO, now we can change these to actually be pipe values. But wait, okay. Hang on, how will this work? Because we don't, okay, the problem is we don't have a way to refer to a location for the pipe handles. It's just a value. I mean, I guess it could still be on the stack. We're just putting another value there. Yeah. So that's fine. So we need to change forward standard. Yeah. We need to change this now. So here, these does not refer to these anymore. These should refer to like pipe. Well, I guess thread shared. No. We actually changed the whole thing here. So here we're saying like pipe. So add pipe. No, we don't add a pipe. We actually just set a pipe. We add a pipe from outside. That's right. Okay, so let's forget about this. Let's just say that we get a pipe. And then we store it. We just assign, basically we just assign a key to a pipe. Yeah. So standard in, we don't actually do that. We just say this is going to be config standard in. So we add these pipes here. And then this would actually be standard in handle. These are handles now. Okay. So now we can do that. There we go. Okay, now this is actually not the pipe itself, it's the handle. So this would be the handle. And the pipe would be get pipe, standard in handle. In PHP, I would F close handle exit. Okay, cool. Last time I touched PHP was maybe 12 years ago. $11 years ago. Or 10 years ago. Yeah. It was basically my first web dev job. I started like 2015. Yeah. Are you a PHP developer? Jehovah says net worth. Hope I didn't say anything weird by saying your name. Okay, you are not the pipe, you are the handle, and then the pipe is get pipe handle. Great. Same thing here. All kinds of code. There's F open, F close, and F write. All right. Do you do PHP for general programming, not just servers? Process IO. Right, so this also changes now. So here we actually need to say yeah, the process I closable. So this we actually need to create this handle here. So self context add closable, and this is the closable. And then we set this to be this handle here. And you are the handle, so we need to get the closable by saying context get closable handle. And the same thing here. This is a handle get okay. That was it. Unsupported instruction. All right. Oh yeah, I think we don't implement the pipe instruction, right? So let's do pipe. Oops. So we should have the result here, okay. We'll do the kind of the same thing as fork. So let's do like pipe handles equal to add a pipe. We don't really have the pipe yet. And then we're gonna do this to set the result here. And this is now a pipe with the pipe handle. And then at the end, I think we just continue, yes, execution. All right, so what is involved with creating a pipe? So basically, we want to create a pipe here. So this is the instruction, so I'm just gonna say this. All reasons, debugging, test codes, find typos. All right, cool. How long have you been programming? So let's see. Okay. Now, we need to create the pipe. So pipe is going to be equal to a stream u8 init reader writer. We don't have stream, so let's import that. And you need an allocator, and then we need a label. I'm just gonna say pipe and a config, which I'm gonna leave empty. And so we'll add this pipe and we get a handle to it, and we store that in here. And now this is always here, so we always do this. And there we go. More than 25 years. Okay. Cool. Kind of same as me then. Self-hosting. All right. Do you mean self-hosting? Do you mean self-taught or because self-hosting to me means that you're hosting your own servers or something. Right, this needs to be a try there. There we go. All right. There we go. And it still works. Good. Okay. I kind of forgot what we were doing. Yeah, okay. So we changed from pipes. Now the values are actually handles now instead of being... So this is all now fully serializable, which is really nice. Which means we can kind of create... Well, it means that the instructions are also fully serializable, because we can just like serialize and deserialize. So that means that we can actually compile to a source file, which is in the intermediate format, and then later decide to... It kind of like bytecode, and then later decide to actually interpret it. So that is awesome. And yeah. All right. Let's see. All right, cool. So, what do we do now? Okay, so we did the handle thing. They are now handles. Very good, very good. We also actually have closable handles. So these are these can be any closables. So it could be processes, etc. So anything that implements the closable interface, we can now store and wait for until it's closed. So that's also pretty cool. Okay, next step is, well, this is already done here. Yeah. Now we don't really have implemented these things, but you know, we can do it. Next step, I see kind of two paths here. It's like we continue with implementing more of the pipeline things, which would be next would be, so we have the basic pipeline stuff happening, but it would be something like execution result of a pipeline. Where do we have this written down? Maybe we don't have it. New pipe. Where's fork actually? Oh, so we have threads. Fork, wait for a thread. Executables, wait for process or processes. Well, actually, it's more. What the hell? I guess executables is more closer to the truth. We can't just spawn processes. We spawn executables, and then we can wait. But we can't wait for that. I guess executable. We have stream as well. We have like, okay, pipes. We have new pipe, and then we also have stream pipe blocking. And of course, this is blocking as well. Executables, we have execute. All right. Okay, so what are we missing here? What are we missing? Maybe we should try to... Maybe binding is one thing we should do, because it kind of completes the whole idea that this is a good pattern, maybe. So by binding, what is that? That is basically doing this. And then you could use, so this wouldn't actually output anything to stand it out, but you would store the value, store the result in P, and then you would be able to access it later by doing something like this. You can also access the exit code, or standard out, or standard or this, which would so this would echo standard out. Well, it would echo hello. This would echo hello, actually with a new line. This would echo nothing. And this would echo whatever exit code, which is 0. All right. So this would be the target maybe for the next step. And what I want to do later, because once we have that kind of makes us do certain things, like defer this, have this run in a separate context that we actually want to store this in some kind of in-memory buffer, and assign it to P, to this value here, this struct basically here, because we don't really have this yet. So that is one thing we could do. Another thing that I want to get to, so this is the binding. Another thing that I want to get to is blocks as pipelines, or just blocks in general. But a block is it's just this. You have a block, you can have several statements in here, you know. and that's easy enough. I don't think this, does this actually work now? No. Unsupported expression, right? So the block expression is not even supported. So first step is to get block expressions actually compile. Next step is to be able to have them as a pipeline. So you pipe this into something that has to have a specific behavior, which is that this block will probably spawn in its own thread, and then this thread will have its, like, it would connect its output to this pipe here. So it's kind of like an executable. It's just that it's gonna it's gonna spawn in its own thread, and then at the end of this statement, like if we only had this this statement here, at the end of the statement we would need to wait for this block to complete before we continue execution down here. But in a pipeline, we still need to wait for it, of course. However, the waiting kind of happens with the last process here. So this will spawn in a thread. It will go ahead and start executing the statements in here. Now, these statements actually does wait as well. So this is an executable which will spin up and everything. However, this is a statement in itself inside the block. So this would also wait for this echo to continue in this thread. So in the thread we would wait for this statement to complete. However, the outer thread will still continue doing things. So it will still continue like creating cat and connecting this pipe and stuff. But this will wait for this to echo out, which will echo out into this pipe and into cat. And then this would do that, echo again, and this would echo there again. And once we're done with that, then this block is done. So then what happens? Because kind of what's happened before is, like, in this case, echo would be done, so the pipe would actually close. But here, I think it shouldn't close until the block is done. Oh, I think that happens if the thread closes. No, wait. Okay. How would this work actually? Yeah, this is something that I need to figure out here. So basically we would have to, this is like the next major step for pipes. And once this is done, we could use these blocks as part of a pipeline, which also in extension would make it a lot easier to make function bodies also work with pipelines, I think. So we've got this part, which is kind of like a lesser painful, I guess, version of this, maybe. So I'm not sure if we want to do this first or if we want to go straight for the main course here and just do this directly. Because I think once we have this will become more trivial, I think, to do. Perhaps. Maybe it's like two different beasts. Are you trying to hack me or something, Jehovah? You found the keyword. Exit the echo. Yeah. Okay, so this I would have to figure out a little bit, but I will have to say bye-bye now. No? Okay, good. But yeah, that's gonna be it for this time. So thank you very much for joining me here, and I'll see you later.